Okay, this is Mr. Bloom. I'm talking about Delta Math compositions. When we're doing this, we're looking at two compositions and they give us choices. But the things I've got to be thinking about. This shape is my final resting place. And this shape is my original. How do I know? Because this has got little primes in them. So it's ABC, this is ABCD. Right now I kind of know that things have come through with this and they're doing fine. But if this is my original, I've got 1, 2, 3 units and this is 1. So this is a third. So this is a dilation, okay? And this is the scale factors 1 divided by 3, okay? So I've got a scale factor. This is a third of this is this. Now, the next thing is what's going on. Okay, so I've shrunk it, but now when I do that third, this is going to be a third closer as well. So you got to keep in mind, I'm not only making it smaller, but I'm making it a third closer. So now that third is 1, 2, 3, 4, 5, 6 away. So now this is going to be 2 above right here. And then it's going to be 1 out because this is 1, 2, 3. So not only 2 above, it's 1 out. So right now I'm here and I've got to rotate it up here. Okay, and that's going to be 2, 1 up here, and that's a 90-degree rotation clockwise. But I've got to do a 90-degree rotation counterclockwise because it's counterclockwise, so that means 270. Okay. So now, as I cursor this up and submit my answer, and I say yes, oh gosh, we're right, and they're going to show us what's going on. So it's there, and then it's a third the size. Okay, so we have to be thinking there's two compositions that are going on with this. This one's a tougher one. And how did I know it was going to be a rotation of 90 degrees, say? Well, those are the only rotations we have. But the big thing is corresponding sides were perpendicular to each other. Okay, and that's how I knew that they'd have to be a rotation. If I have a reflection, corresponding sides, I can see the corresponding points being on a line perpendicular to them. If I'm looking at a translation, corresponding sides are parallel to each other. So those are the things I'm thinking about when I do this. Let's go into another problem. Now in this problem, it appears that the shapes are the same. Okay, and I'm going to check. I'm not just going to guess. DE 1, 2, 3. DE 1, 2, 3. So the shapes are the same. So this is an isometric transformation. There's no dilation involved in this. So now when I'm looking at this, I'm going to go, well, I could just slide this over, but you see how this orientation is different from this orientation? This looks like it's going to be a 180-degree rotation. Okay, and then a translation. And let's talk about that. If I go 180 degrees from here, I'm going to be up here with A. Okay, 180 degrees from here, from E, I'm going to be here. So that seems to make it okay. All right, but 180, if E is at -1, -5, -1, -5 times -1, which is 1, 5, 1, 1, 2, 3, 4, 5, I'd be right here. I just have to translate E 1, 2, 3, 4, 5 units. So it's a 180-degree rotation, okay? And I don't have to go clockwise or counterclockwise with that. Doesn't matter, it's going to end up the same. And then I'm going to do a translation because I'm going to slide it over. So it's going to go from here, 1, 2, 3, 4, 5. And I'm going to go to the right. 5 units. Okay, now I've got to get my submit button and hit yes. And we'll watch what happens. Well, they went left 5 units and then rotated, but right, that rotating and then going right 5 units will do the same thing. Okay? Now, new problem. Determine a series of transformations that would map polygon ABCD onto polygon A prime, B prime, C prime. This is a dilation first, so it's going to be a 3 to a 1, so it's a third the size. Okay, that's my first thing. Okay, Now, that's going to shrink this down, and it's going to be a third the size, a third the distance. This is 3 out, and this is 1, 2, 3, 4, 5, 6 up. So now a third of 3 is 1, and remember it was 2, so I'm at 1, 2. And now this is my new A spot right here at negative 1, 2. And I'm going to go 1, 2, 3, 4, 5 units to the left. I'm going from A to A prime. So my left translating 5 units. Okay, now submit my answer, and I seem to be right. Now, every time I answer, whether I'm right or not, oh, nope, I should say we're going to get the next one wrong. I want to show you something. Okay, first of all, we'll do the right question, then I want to make sure you understand that there is a solution to this. So I got a new problem. All right, so this one is another transformation. That's dilation first. So I've got 1, 2, 3, 4, 5 of my original, or 6, excuse me. Oh, nope, it's 5 length on my original. And then from A to B, I'm going from 2 to 12, so it's 10, so it's twice as big. Okay, so it's a dilation. That's twice as big. Now, since it's twice as big, you got to keep in mind what's happening. But they'll do probably, and then if it's twice as big is that it's going to be here and this is going to be here. So my new A is up here at 2, 4. And now a 90-degree counterclockwise rotation, or excuse me, a clockwise, 90-degree clockwise would bring it to the original. But we were doing counterclockwise, so it'll be a 270 rotation. If I want to do a rotation, it'll be a 270 to do this one correctly. But remember, we said we're going to do this wrong. So let's say it's 90 because, you know, that's really what's going to be. But if I put this in, okay, if it's counterclockwise, this is not counterclockwise. I just want to make sure you see what happens when you're wrong. So we go down and we see, oh, there's that 270, and they'll do the rotation and then they'll grow in. And we did the shrink and rotation first. So they'll do this, and they'll do that's 90 degrees. That's what our answer was. And so the dilation centered at the origin with a scale factor of 2 followed by a rotation 90 counterclockwise about the origin. This does this. Okay, so they're actually showing us where our piece would have been. And we are looking here at a rotation of 270 like we talked about with a dilation of 2, but we could have flip-flopped those. We could have had it grow and then done the rotation, or done the rotation and then had it grow. Okay? Now, that way you can see both things and see what's happening. Let's do one more problem. Now I've got this situation where I'm going to make something grow, okay, or shrink, I should say. So I'm going to shrink this again. This is another dilation. It's a third, okay. But they've been doing the transformations and then the dilations. And we can do that too, but it just seems to be easier to look at where it's going to end up. So remember, every time we shrink something, and this is going to be a third, this is out at 6, and this is out at 3. So I'm out 6 and up, down 3. Down, out 6, down 3. A third of those is out 2, down 1. So I'm here. So my A will be right here, and I'm going to slide it up to this position. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to shrink it, dilate 1/3. And I'm going to translate it up 8 units. And we're going to go ahead and get that done with a submission. Okay, so we see our submission, and we still have 30 seconds on the 10-minute video, so let's try one more. Again, this is one very similar to the one we just did. Okay, I'm going to shrink this down, and why am I just going to shrink it? See how AB and AB are parallel to each other? This means I'm translating because they're going to be parallel to each other. There isn't a rotation involved or a reflection because they're in the same orientation. So I'm going to shrink it. By how much? AD is 2 and A prime, D prime, I should say, and AD is 1, 2, 3, 4, 5, 6. So I'm cutting this, boy, I'm cutting it by a third. Okay, so I'm bringing this, the A's at 3, 3, negative 3, negative 3, and I'm going to bring it down to negative 1 by multiplying by a third. And then I'm going to slide it up 1, 2, 3, 4, 5, 6 units up. So I'm going to dilate 1 divided by 3 and slide it up. How many units did we say? 6. So we're going to translate it up 6 units. Submit. Okay, I hope this is helping on how to do this particular portion of your delta math. Now remember, what this is your transformations visually, okay? And it's the composition of shapes is what we're doing. That's that composition of transformations. It's shapes, and that's the one you've been doing. Okay, have yourself a great day.